Welcome to the long-awaited, seems like, first part of Chapter 2, this Section 1, talking about the Earth. All right. I know the notes were printed and Section 1 and Section 2 are all together, but the videos are going to be separated out. So this video will cover everything from Section 1. And then hopefully I'll get Section 2 out a little bit later today. So let's get right into it. I did not post the Schools PLP in this particular video because I was trying to get it out to everybody. I know y'all been waiting a while for it. So if you need to know the PLP correlation, just let me know and I'll be happy to share that information. But with no further ado, let's jump right in. So we're talking about the Earth and space in this first part. And so we're going to start with the solar system. And our solar system is known as the Milky Way. It is formed by the sun, which sits in the middle of the solar system, with Earth and 7 other planets orbiting the sun, okay? And in that order, we are the third planet out of 8. Okay, so you have the sun in the middle, then Mercury, Venus, Earth, Mars, Jupiter, Saturn, Neptune, Venus, Uranus, I believe is the right order. Don't quote me on that. It's been a while since I've named off all the planets in order, but I know that Earth is for sure the third planet out of the 8. All right. And as we said just a second ago, in the solar system, Earth is orbiting around the sun. It is taking an elliptical path, traveling around the sun. And for the Earth to make one complete revolution around the sun, it takes 365 and 1/4 days. Okay, this is where we get our years from. One complete orbit around the sun is a year here on Earth. Now, if you notice, it says 365 and 1/4 days. That is because on the every 4 years we have what's called a leap year. All right, so we could take one trip, and then 2 trips would be 2/4, 3 trips would be 3/4. On that 4th trip, being the 4th year, we have an extra day in the year, and that day is put on February 29th, and we call that the leap year. Now, while Earth is orbiting the sun, it is not sitting still on this orbit. It is spinning on an imaginary line that runs from the north to south pole called an axis. Okay? And for the Earth to spin completely around on its axis one time, it takes 24 hours. So 365 and 1/4 days to orbit the sun gives us a year. One 24-hour cycle on the axis gives us our days. Okay? And so if you imagine imagine the planet and the North America, Western Hemisphere part is facing away from the sun on this 24-hour period. That means we're having nighttime. And as we face back towards the sun, we are having daytime. Okay? So we have sunrise and sunsets because as the Earth is spinning, once we spend nighttime, we're getting back to face the sun. You see the sun come up. And it's also why if you look at the sky during the day, the sun seems to move. It's because the Earth is spinning on this axis. All right. Now, not only is the Earth orbiting the sun, not only does the Earth spin on its axis, but the Earth also is tilted on its axis, and it's tilted 23.5 degrees. This tilt gives us our seasons as we go through the course of a year. Okay, and you can see this a little more clearly on page 35 in your book. Okay. When the North American section is furthest down furthest away from the sun on the tilt, we're having winter, and as it creeps back up towards the highest part, we're having spring, and then as it gets right there in front of the sun, we're having summer, and so on and so forth. And that's because of the 23.5 degree tilt that gives us our seasons. And that's the answer to number 5 as well. What does this cause on Earth? It causes our seasons. All right. Number 6. So let's talk about the seasons. Now, in space and on Earth, we have 4 different days that give us different seasons. And the first ones we're going to talk about are the solstices. Okay? A solstice is the 2 days a year when the sun is either furthest north or the furthest south of the equator. The summer solstice occurs on June 20th or June 21st, and it is the longest day of the year. That's when we have the most hours of sunlight is during the summer solstice. The winter solstice occurs on December 21st or 22nd, and that is the shortest day of the year. That's what we call the winter solstice. Okay? That's the day that we have the longest amount of nighttime. All right, so the summer and the winter starts on days called solstices, but then you also have equinoxes. And the equinox is the day that the sun is directly even with the equator, okay? An equinox is the 2 days of the year when the sun hits the equator directly, making day and night equal length. So you hear equinox, think equal, okay? These occurred during the vernal equinox, which happens around March 21st. It's also known as the spring equinox. And then the autumnal equinox, or the fall equinox, happens around September 23rd. So we are right here creeping up on the spring equinox. It should be around March 20th or 21st this year. All right, so remember, in review, the summer and winter start on solstices. The spring and fall start on equinoxes. Now, let's talk about the makeup of the Earth, okay? Earth consists of 4 layers. It's the crust, the mantle, the outer core, and the inner core. And I know your book tells you it has 5 layers, and that's because they have divided the mantle into the outer mantle and the inner mantle. We're not going to worry about that. We're just going to call it the mantle, okay? So what you're walking on, what you're sitting on, what you drive on, that is the crust. That's the outermost layer. It's about 30 miles thick, okay? And then you get to the mantle, and it's about 1,400 miles thick, all right? Excuse me, I'm sorry, 1,800 miles thick is the mantle, followed by a 1,400-mile area known as the outer core, and then a 700-mile area known as the inner core. And the outer core and the inner core are both made up of melted metals, okay? And you can see that here, okay? Very, very extremely hot temperatures inside the Earth. And that is partially have to do with volcanic eruptions, and why you see magma and it's hot. It's because it's the mantle that the magma is coming from the mantle in a volcanic eruption, and the inside of the Earth is very, very, very hot. Okay, so let's talk about tectonic plates. All right, tectonic plates are giant slabs of rock that the crust is divided into. The 7 continents on Earth: North America, South America, Asia, Africa, Australia, Antarctica, and Europe. Those are your 7 continents, and they all sit on these giant slabs of rock known as tectonic plates. And tectonic plates are constantly moving. Okay, they do not sit still. And several things can happen when tectonic plates interact with one another, and you can see all of those on page 37. All right. Part of this movement leads us to what's called continental drift. There is a popular theory that at one point all of the tectonic plates on Earth and all the continents on Earth were one giant landmass known as Pangaea. And over time, the continents have slowly drifted to where they are now, and this explains the concept of continental drift. You can see it on page 37. It says that as plates have shifted over time, the continents have moved into their current positions, and the movement of the continents is known as continental drift. Okay? And I don't know why that repeated itself, but it did, so let's move on. All right, so now that we know about the Earth and space, and we know what the Earth is made up of, let's talk about some of the features on the Earth. And several of these you're probably familiar with, okay? Some of the landforms on Earth include mountains, okay? Most of you know what mountains are. Plains, canyons, plateaus, which remember plateaus are basically plains with a cliff on all sides. Buttes, which is a higher version of a plateau. And deserts. Okay, and these are not the only landforms on Earth, but these are some of the most common ones that you're probably the most familiar with. All right. So let's talk about a continental shelf. Okay, a continental shelf is the edge of a continent that extends out under the water, and most of Earth's marine life lives at this level. Okay, once you get out to the shelf, it begins to slope, and beyond the shelf is the continental slope. And as it goes down, it rises up one more time in what's called the continental rise, right before reaching the ocean floor. And you see that designed out here, okay? Now, obviously, if you've been to the beach and you've been swimming in the ocean, you're not swimming out to the continental shelf. It's way out there. You have to get to the point where you don't even see land, okay? So it's very deep where the shelf begins. It is not necessarily a area that you could experience for yourself, but it is where the continent kind of drops off and goes towards the oceanic crust. And the oceanic crust is what we know of as the ocean floor. All right. Now, there are several landforms that can exist both in land and in water, and those are mountains, valleys, and even volcanoes. Okay. In fact, when an underwater volcano erupts, the lava that floats to the surface cools and creates islands. Okay, so like the state of Hawaii, that's how Hawaii was was formed, thousands and thousands of years ago, is that an underwater earthquake erupted and formed the islands we know of as Hawaii. Okay, so these are landforms that can occur both in the ocean and on land. All right, so let's talk about erosion, something that affects the earth, affects the land. Okay, erosion is the process by which rocks and soil slowly break apart and are swept away. And it usually happens thanks to weathering. And weathering is is a phenomenon where air, water, and wind or ice slowly will wear away rocks into smaller rocks, into soil, gravel, into soil, and then erosion can carry that material off somewhere else. Okay. What I told my traditional classes was, imagine you have a rock with a crack in it, and then water gets into that crack and it freezes. Well, when water freezes, it expands to become ice, and so it could crack that rock apart. So now what was a rock could become two parts of a rock, and that's part of weathering. Okay, and so weathering happens when wind, water, ice wears something away, and then erosion occurs when that material is swept off somewhere else. All right. Number 15, let's talk about the Ring of Fire. Okay, the Ring of Fire is located on page 40 and 41. And the Ring of Fire is a circle of volcanoes and earthquake activity along what's called the Pacific Rim. It starts around outside of Australia, far east Asia, up along the eastern Asian coast, across over to the western coast of North America and South America. And you can see this on the next slide. You can also see it in your book on page 40. 75% of the world's volcanoes are located here in this area called the Ring of Fire. And it's mainly because of the large ocean plates that rub against plates in Asia, Australia, South America, and North America, creating tremendous pressure and eventually resulting in volcanic eruptions and/or earthquakes. Okay, most of the earthquakes that happen in the world happen in this area, but earthquakes are not exclusive to this area. Earthquakes can happen other places too, but this is the place that is most prone for that to happen. And here you see it again there. Again, Far East Asia, up along the eastern Asian coast, over down to the west coast of the United States, which is what California is so susceptible to earthquakes, down the west coast of South America. That is the Ring of Fire. Okay, so what causes an earthquake? Well, earthquake is a violent shaking of the Earth's crust, and they are typically caused along fault lines. Fault lines are cracks in the Earth's surface where plates have been moving. Okay, and typically when an earthquake happens, two plates collide and then suddenly slide against each other. They slip beside each other, and when that happens, it causes a rumbling and a trembling in the ground, and that trembling is known as an earthquake. Okay, and if an earthquake happens near a coastline or in an ocean, it can result in what's called a tsunami. Tsunamis are caused by earthquakes that either happen near a coastline or completely underwater, and when they occur, they are giant ocean waves that are powerful enough to sweep away cars, level buildings, and flood entire areas. Okay, so these giant ocean waves caused by earthquakes are known as tsunamis. Now, I have posted a video in this folder that says rare footage of the Japanese tsunami of 2011. It's about a 3-minute video by National Geographic. Please watch that because it will explain earthquakes and tsunamis a little more, and you can really see the power of what a tsunami is capable of. All right, next question talks about volcanoes. So what is a volcano? Volcano is a mountain that erupts in an explosion of molten rock, gas, and ash. Volcanoes form when dense ocean plates dive underneath the less dense continental plate, and that magma that has been displaced has to go somewhere, so it usually comes up through the mountain in the form of a volcanic eruption. It's one of the main reasons why you often see volcanoes along coastlines is because of the heavy ocean plate and the less dense continental plate that have to interact with one another for a volcanic eruption to occur. All right. When you see a volcanic eruption happening, the lava or the magma that you see is usually melted rock coming up from the Earth's mantle. All right, and so I've also posted a video on in the Chapter 2 folder from National Geographic called Volcano 101, and it goes into greater detail about how volcanoes are formed and how they erupt, so please make sure you watch that as well. All right, and that's what that is. Please view the video attached titled Volcanoes 101. All right, so make sure you watch that. All right, so number 19. Volcanic eruptions are they're disastrous. They can be very dangerous. I mean, they can be life-threatening, but they can also be very beneficial, and that's because when volcanic lava cools and forms into rock and is breaking down through weathering and erosion, it actually forms a very fertile soil that is great for plants to grow in. So it helps the vegetation that way, but it can also help animals around that use that vegetation for food. So even though volcanic eruptions can be very disastrous, very deadly, they can also have benefits down the road. All right, now let's turn our attention to water. Okay, this is going to be pages 42 and 43. So about what percentage of the Earth is water? Earth is about 71% water, and most of that is found in the world's oceans. Okay, in fact, you'll see this later on, but Earth only 2% of the water on Earth is actually fresh water. The rest of it is salt water, and salt water is what we have in the oceans. Okay, so if you take 100% of Earth, only 29% of the Earth is actual land. Now think about all the land on Earth. Now imagine how much water that is, and how vast those oceans are. Right? It is a very crazy thing to think about. All right. So let's talk about some examples of water on Earth. All right. When we're talking about water, we have three kinds of water. You have salt water, you have fresh water, and you have brackish water. Okay. Fresh water and salt water are self-explanatory. Brackish water is when you have an area of fresh water that meets an area of salt water. For example, if you were to get into the Alabama River on a boat and take it all the way down to Mobile Bay, that eventually spills into the Gulf of Mexico, that Mobile Bay is brackish water where fresh water and salt water are mixing. Okay, so here are some examples of bodies of salt water. You have oceans, you have seas, you have bays. Those are all saltwater bodies. Okay, you have gulfs, like this here, looks like it's along either Gulf Shores or maybe Panama City. Okay, when we go swimming at the beach, for most of us, we are going swimming in the Gulf of Mexico. All right, for most of us. All right, there's other beaches and other bodies of water, but that's where most of us probably end up going. All right, so those are all examples of salt water. Now here are some examples of fresh water: rivers, creeks, lakes. Okay, those are all freshwater bodies. And then brackish water, like I said, is where you see an area of fresh water that is mixing with an area of salt water. And it kind of creates this cool effect here because of the difference in densities of the water with the salt and no salt. All right, so that is brackish water. All right, so out of all the water on Earth, no matter what happens, the amount of water on Earth is always going to be the same. What changes is what form of water it is. Okay, so it's possible. So it's possible for the amount of water on Earth to always be the same because of the hydrologic cycle, also known as the water cycle. All right, the amount of water on Earth will never change, only the state or the form that the water is in. So let's talk about that. Okay, the states of the water cycle. First, you have evaporation, and that's where water is heated up by the sun's rays, and it rises into the atmosphere in the form of a gas. Once it gets there, once it rises high enough, it goes through condensation. Condensation is where water vapor begins to cool, turning back into liquid water, where it becomes stored in clouds. Once a cloud gets heavy enough, it will drop that water back to Earth in the form of precipitation. Okay? Once the cloud gets heavy enough, the water it contains falls back to Earth in the form of rain, sleet, snow, or hail. And then once it falls back to the Earth, it is collected in rivers, streams, creeks, gulfs, bays, all these bodies of water, where the whole process starts over again. All right? So here's a picture of it. All right? You got the body of water that's been collected, evaporating into the atmosphere, goes through the clouds and condenses, turns into liquid water. The cloud gets heavy, falls back to Earth in precipitation, and then it is collected again, and the whole cycle continues. All right? So as we alluded to just a minute ago, how much of the Earth's water is fresh water? Well, that would be 2%. Okay, of the water on Earth, only 2% is fresh water. So it tells you how big the oceans are. Think about the Great Lakes. Think about all the rivers you've heard of. Think about creeks that you've been in. There are a lot of freshwater bodies on Earth, and of all the fresh water on Earth, that's only 2% of the water that the Earth has. Okay, the rest of it is salt water. Most of the fresh water on Earth is actually stored in glaciers and ice caps. Okay, 98% of the fresh water on Earth is stored in glaciers and ice caps. So think about all those rivers, the Amazon, the Nile, the Mississippi, the Changjiang in China, creeks, lakes, the 5 Great Lakes, those are all freshwater bodies, and yet that's still not even a full percentage of the fresh water on Earth. So it really lets you know how much of a water planet this really is. All right. Finally, groundwater. This was not in the book, but groundwater is water that is stored in an underground layer of rock known as an aquifer. Okay. If you have been to Prattville and you go to one of the artesian wells, there's one over there behind the jet pit by the funeral home downtown. There's one down by the creek on Doster Road. If you're out in Otagoville, there's one by the softball and baseball fields, what they call artesian wells. That's water coming out of the aquifer. That's groundwater. It's fresh water. It's clean. It's drinkable. But that's water that is being stored in a aquifer, which is a rock layer under the ground. Also, I asked you about where most of the salt water is. Most of the salt water on Earth can be found in the oceans. All right, and I know that's a typo. Let me fix that real quick. It should say most of Earth's salt water can be found in the oceans. So there you go. All right, very good. All right. All right. All right. So then, speaking of oceans, what is the world's largest ocean? That is the Pacific Ocean. The Pacific Ocean is by far the world's largest ocean, and is believed to cover 63.8 million square miles. Okay. Most of y'all can't handle going on a 200-mile trip without getting bored. Imagine 63.8 million square miles. That's a lot of water, okay? Like I said, Earth is very much a water planet, and by seeing numbers like this, it is clear to see that that is true. Okay, so that is going to wrap up section 1, talking about the Earth. When we come back, we'll be talking about weather and climate, and that will be in section 2. And again, I will try to get that out to you today. If not, it may be Friday. If you're watching this in 2021, we have state testing coming up. So you will not have anything from me again until Friday. So get these watched, and we will get back with the quizzes and everything like that on Friday of this week. All right. Y'all have a fantastic week. Good luck on the state tests, and we'll talk to you soon.